Hi, everyone. Really great to join everyone today. My name is Austin Yu. I'm an investment manager at Taiwan Capital and excited to chat, especially a week after RSA Conference. We all know this is a week of decompression and really be able to process what we've been able to be bombarded with last week. And I'm really happy to be joined today by Dr. Chase Cunningham, also known as Dr. Zero Trust, and Cheng Wu, General Partner of Taiwan Capital. Gentlemen, if you wouldn't mind, I'd love it if you guys could introduce yourselves, just a little bit of a brief background, and perhaps we'll have Dr. Zero Trust go first.
Sure. So we got too many doctors on the thing. So yeah, I'm Chase Cunningham. I'm retired Navy. I worked for the National Security Agency for quite a while. I also worked for Forrester Research and have done a bunch of consulting with other organizations and published some books that probably 5 or 6 people have read.
It's an honor to participate in this session. My name is Cheng Wu. I'm the general partner for Taiwan Capital Technology Fund. Just a way to introduce myself, I'm really more a serial entrepreneur who turned investor in the past couple of years. My background is pretty diverse, but I am particularly focused in hard tech type investments, and in which data security is a particular aspect of interest. And so here I am. Thank you.
Great to hear from both of you guys today. Week coming off of RSAC is always a pretty big decompression time for us. And I think some of the big topics that we saw last year were around XDR, tool consolidation, API security. And this year, a lot of open source security, some supply chain security. But I think the big and new exciting topic this year is really around AI and ML, and how do we secure the data that's really fueling these engines. So Dr. Cunningham also had a really amazing speech about an hour-long talk that was really well attended on verifiable credentials and the future of enterprise security. So if you wouldn't mind, Dr. Cunningham, I'd love if you could just share a little bit about what you see here in the verifiable credential space, and just a quick summary and a brief overview of of your speech that you gave at RSA for those who weren't able to attend.
Sure. So the big thing that I was really trying to get out there across the space was identity and access management has kind of hit the peak of where it's going to go. The next thing is going to be moving towards this sort of fully digital presence. And we already have, this is not a pipe dream. This is not something that people are just talking about. There are organizations that are using this capability where you don't need to break out your physical passport to also check into a place with a password and all this other stuff. So the whole way that we're trying to put this out to the market is using some of the newer systems that are out there. You can be passwordless, you can be fully digital, and you can cross borders, literal physical borders, into new countries and never bring your passport out. And if you can do that with your passport in such an archaic and antiquated system as the legacy paper-based passport system, imagine what we can do when we're fully digital on the far side of this.
Yeah, that makes total sense, especially because I think access and authorization now goes beyond, especially in the digital realm, goes beyond just humans accessing assets, but also code accessing assets and other machine processes and applications as well. And in terms of what you see in the privacy preserving space, with a lot of these data assets being all thrown into the cloud and with AI running on top of them, what are some of the essential elements that you feel like enterprises need to pay attention to? And how does this verifiable credential concept really be able to harden this process of protection?
Well, so I always ask the people, if you look at this, right, this is my wallet. Obviously, I'm poor, so there's no money in it. But really, if you look at my wallet, what does my wallet have? It's got my driver's license. It's got my military ID card because I'm retired Navy. It's got my credit card, that type of stuff. But this is what people would accept as, if I give this to you, that's my identification. In Dominis Patria Filisanti, that shall be. Now, what's crazy, if I hold this thing up, which is my iPhone, how much more information is stored in this than there is in this? And why would I not be using this to power my identity, my online presence, my interactions, my passwords, all those other things? It's actually kind of stupid that we're still using these when we should be using this. And that's where the market is gravitating and going. Passwordless is achievable. Being fully digital is where the market is going to evolve to. So we in the security space and enterprises should stop trying to fight the tsunami that's coming our way and start embracing it, because this makes everyone's life better. That's why we use it.
Absolutely, absolutely. And just a quick recap of what we've seen in the past at RSA: XDR, tool consolidation, API security, endpoint protection, and a dozen different frameworks that have encompassed RSA over the past few years. But really, what we saw this year was something new and exciting, which is with the carryover of the bad word in the industry, ChatGPT. We have AI and ML, and how do we protect all the data assets that are fueling this engine? And as Dr. Cunningham has presented already at RSA his vision on verifiable credentials in the future of enterprise security. We'd love to hear from Chang and your ideas on decentralized authorization and how this should be done right at the enterprise scale.
I guess this subject is a little bit broad because it's tied to a couple of basic notions, and specifically in the context of data security. And I always like to talk about the fact that Google started the notion of when you do a website access, you should always try to use HTTPS as opposed to HTTP. At the beginning of that, people think of it to be, why do you encrypt every traffic? But the notion there that they will try to promote is the idea that access through web should always be secure. It should not be a discretion whether or not it's secure or not. And likewise, it's tied to data. And if you look at the data access today, and data access is controlled by really a layer which control access control. So you have the notion of providing a layer of control over the data that you try to protect. And by making the presumption that data may not be securely stored, may not be securely transported, may not be securely accessed. And therefore, you need to add a layer to protect it. I think that it's getting to a level, especially when you look at it from a data and machine learning or AI perspective. If you have data which is compromised in the era of AI, where every application is expected to have some embedded AI intelligence today. And when you think about that, and you have machine learning accessing data to build a model, and the data are not trustworthy, how could a model be? And so there's a notion, from my perspective, that the data should be inherently secure. And in order for that to be inherently secure, it needs to be protected all the way from the data source at the beginning, and therefore tied to data source and data storage. And from there in transport, which is easier because you can always encrypt the data after that, and then put them into a two-way SSL connection between the two endpoints. And when it comes to data access in particular application or software as a service or databases, that's a little bit more complicated issue. Because if the data usually is not encrypted, then the access to the data is difficult to be 100% secure. In order to secure these database access, there need to be a notion, I think, that data and how data security is important or relevant should be permanently bound together as a declaration of the data. And that ability to bind them together need to be a policy binding that's associated with the data throughout the life cycle of the data. And in order to do that, as we see today in the environment, that if you look at access control and device control and device identification perspective, you see IDM as a category which evolving to become as a service. You see authentication in the middle that's evolving to become as a service. And you see less of access control to become as a service, but it will be. And the notion here is to say that these as a service provide a global multi-cloud wide footprint that allow data to be governed, that allow device or algorithm or application to be identified, and therefore registered and centrally controlled. The part that's most difficult, however, I think is authorization. Because authorization is an issue, one that's tied to the data that would grant authorization. And so you start with the owner of the data, but the owner of the data may delegate certain sub-rights to other downstream users of the data that can be authorized too. And therefore, they form a relationship of authorization delegation from one party to another. These things involve issue of distribution because delegation of rights are inherently distributed. But there's also a performance issue that centralized control of authorization simply does not scale. And therefore, they are bound to be distributed control, and from distributed control to distributed enforcement of access control. And that these frameworks actually have been in progress for a long time, except that they were not done in association with the data that needs to be protected throughout the life cycle. The challenge really is, at a high level, data should be inherently secure if you want to protect it, and it should be secure throughout the life cycle, and that the authorization should be a feature that builds on top of that, and that in order for it to scale and support and protect the data throughout the life cycle, the authorization layer needs to be distributed because it needs to follow where data is, how it's being accessed, who are granted the authorization to access it, wherever they happen to be. So that I think that explained at a high level that I think the access control not only need to be distributed, but also need to be tailored not to protect the data which are stored inherently in security, but to say change that paradigm from that data needs to be protected because they are in security store or access throughout the lifetime, to a paradigm where data is protected throughout the lifetime and would continuously be monitored for the compliance to what they are supposed to do.
Yeah, thank you for sharing that vision. I really think this is where enterprise security is trending, and also with what Dr. Cunningham shared earlier about verifiable credentials, this would definitely slot into many aspects of protecting data in this way. Dr. Cunningham, a question for you. How do you see verifiable credentials trending towards decentralized identity systems as well?
Well, I mean, everything is becoming decentralized, whether we like it or not, just by the growth of the internet, cloud, and distributed systems, and et cetera, et cetera. So the days of us having, you know, a bounded enterprise that you can take care of, and every one person having one account to log in to do all the things is just so far gone. It's only getting faster. So if you're going to be moving into a digital future, you are going to be distributed. You're going to be dispersed. And if you're not aligning your practices, technologies, and strategy to enable that, you're basically swimming against the current. And unless you're a salmon, that doesn't work out for you too well. And honestly, for the salmon, it doesn't work out too well. They die at the end of that journey. So it's not a smart thing to try and go counter to where everyone else is moving.
Yeah, no, that's a really great point. And I think this also feeds into confidential data access, which is a little bit of what Cheng was getting at. Gentlemen, if you wouldn't mind, I'd love to dive into this topic and just understand a little bit about how confidential data access works at the core, and what are the benefits of implementing a system such as confidential data access with verifiable credentials to support it.
Well, I think that in order to talk about this, I think it's important to talk about the present state. The present state of data is assumed that the data is not secure, and therefore you need to add a periphery layer on top of that to protect it. And so everything is under the assumption that data can be infiltrated, can be stolen, data asset can be lost, and therefore you need to protect it from that happening. I think that idea create problems where the data, in order to check that. You have to constantly check for violation of how data is provisioned for access and whether or not there's any violation of it. So the fundamental issue for that is because you have not made data inherently secure. So the idea is it possible to, instead of trying to patch the holes that we create, to make data insecurity disappear? Would it streamline data security if data security is airtight and maintained to be airtight throughout the life cycle of data? And if that's possible, would it actually change the way data can be access controlled? If data is always secure, then it will require the ability to identify the party which can access it. Traditionally, we have done so by identifying the human or the devices that can access it, which is really defined by IDM. I think what's really important then is that in today's era of API interconnect based on software as a services, the API gateways and so on becomes the way to control how data is being accessed. So the way to do it, I think, is to say if the programs or the software as a service or API, which represent the algorithm or the programmed entity that can access the data, can be equally authenticated or signed, quote unquote, then they can be treated the same way as IDM entities such as human and devices. And that if it's possible to allow the policy control of these new programmable entities to be managed through the certificate mechanism, the same way other entities like human and devices are, and that binding can be maintained to be persistent, namely starting from when data is created and traced along the line throughout the life cycle data, provided that distributed access control is available. Then it would change the game of how data security, confidential access is achieved. Because confidential access is built based on assumption that we are not going to make it happen that data is exposed to security risk. It presumes that data is always secure, but the cost of data security needs to be minimized, and therefore the ability to discriminate data which need to be security protected versus data which do not need to be security protected, and throughout the life cycle to protect them without adding an additional cost layer or performance penalty layer to protect them. Of course, everybody wants to protect it. So the question really is, what's the cost of protecting it? If you want to protect the data, you can use homomorphic encryption today, but the performance doesn't run. So the whole idea is cost, latency, ability to protect it through the life cycle, and ability to do the binding to make it happen. And confidential computing, I think, is defined by using today's PKI technology, because the PKI technology really provides a way to encrypt the data. That same technology can be extended to provide the ability to identify the authenticity of the algorithm or program or software as a service, and further, the ability to bind those entities with the data that the access rights will be granted to. And that association then needs to be done in such a way that that binding relationship is made available anytime, anywhere, by anybody, whenever data is accessed. Hence, the need for distributed authorization. And so if all these things come together as a framework, that's what we call confidential data access.
Great, thank you so much, Chang, for sharing with us what confidential data access really means for the enterprise. And Dr. Cunningham, I'd like to throw it back to you as the creator of the Zero Trust. And how do you see this framework being applied into Zero Trust methodologies, and especially with the single root of trust being so important and critical for enterprises today?
Sure. Well, number one, John Kindervag was the kind of the creator of ZT. I'm just the guy that won't shut up about it. So all creds go to John for really launching that into the market. I do think, though, that this is exceptionally applicable in the context of Zero Trust, because really, if we look at what we're trying to get to with Zero Trust, I need to remove trusted relationships from systems. That includes people, that includes data, that includes networks, that includes access, all of the things that make the internet and infrastructure run. I need to remove trusted relationships from those. And that sounds like a really hard thing to do. But the funny thing is, if you approach it from the aspect of, well, technology's evolved to where now we can operate at speed and scale, and we can do these things that enable all these trusted relationships to occur by the very nature of the transaction. Well, conversely, if we put the right controls in place and we use the right solution, we should be able to systematically remove all of those inherent trusted relationships, and no one will be the wiser. The best what's the quote that they say, the best trick the devil ever pulled was convincing the world he didn't exist. Like, that's what we're trying to get to in the context of ZT overall. Is I don't want people to know that they're operating a secure environment. Security should just happen, and your transactions are handled by the technology. So where we're going is that is becoming a more common approach to the conversation, and the fact that ZT is as global in nature as it is provides veracity to what we're doing actually makes sense. And I mean, we're on this call now talking about Zero Trust from folks in Taiwan to Hawaii to DC. I mean, we're global in nature. This is where the market is trending and tracking.
Yeah, that totally makes sense. And I think especially with the touch points that you guys have both made, especially with machine scale authorization, how do you guys see the next iterations of authorization frameworks such as ABAC and RBAC playing into this? And how do we really design this so that machines interacting with data can have that we can safeguard those in addition to how humans access data as well?
My quick reaction is actually to tap onto what Chase just talked about. Is the first important thing is to preserve the principle of zero trust. And what I have seen up to this point is all the access control mechanism assume that it is a party to be trusted in order to enforce all the policies. And that's something that's of a particular concern. And second, I think is that in order for that to scale, there's really no other alternative than to go for some sort of distributed access control. We could argue what specific details of access control we use, but we should not argue that distributed control is necessary. So that's one. I think also there is the notion of the moment that the control is distributed, then there ought to be a hierarchy of delegation of rights, because it's impossible for one to be controlling all, but it's much more likely for one who's the owner of the data to control it all, but to delegate it to others for a subset of rights, where these subset of rights are distributed to other parties, where they are linked together in a tree, where they need to be updated in real time. So the question a lot of time is not to distribute the right and to give to other people, but to be able to revoke the rights as needed or when they expire. So it's a two-way street. It's not just a matter of giving, it's also a matter of taking away. And that speaks to the complexity of a distributed access control. And so I would say that all the access control, be it RBAC and other mechanisms, all have their merit. But I would say that the access control, idealistically, if they can be made as a policy decision on top of confidential data access, then you would allow access control to focus on the issue of policy and enforcement of policy. and let it be the issue of the data in terms of protecting the data and make data security an inherent part of data attributes. If that can be maintained airtight throughout the life cycle, then it's, as Chase just said, it should not be visible. It's by definition always secure.
Yeah, that definitely makes sense in applying this on a distributed level to protect the entire enterprise environment. One thing I wanted to bring up, and to quote the former CISO of Johnson & Johnson, Maureen Allison, one thing that she mentioned at RSA is that securing AI really needs to start from securing the data. Dr. Cunningham, I'd love to hear your view on securing AI and ML training data. And what would be your suggestion to CISOs right now that are facing this new influx of data and the need to train on it, and potentially even employees throwing data into these chatbots that they probably shouldn't?
Well, ChatGPT had its first breach notification this week, so welcome to the club. They get to be a part of the pool like everybody else. And it's folks. I think really the biggest takeaway is there's not AI, right? There's no artificial intelligence. Honestly, we should be terrified of real artificial intelligence. That's not something we want. What we have is applied machine learning with lots of process and compute and very good algorithms, which can be used to solve problems. However, like you're saying, where do you get the data from to train those models to make the algorithms better? Because math kind of needs to be fed like a beast so that it can get to full potential. You have to be careful where you get that and how you bring it in. And interestingly enough, people forget this because of the fact that we call it AI. If you throw crap data in, you get crap responses out. So we're at an inflection point where we need to have good data stewardship. We need to have good curation of data. We need to have good control of the data, and we need to have verifiable methodologies to get in front of people putting data into systems, because it does introduce risk. Anything you publish, I'm from the South. We were always told, never write anything down you wouldn't want your grandma to read. Never put anything into ChatGPT you wouldn't want grandma to read. I mean, it's kind of where we need to get to. So folks need to understand that that's how this is supposed to work. And the only way we do that is with technology that operates at the speed and scale of these applied machine learning types of solutions.
Yeah, that's a great point, and I love to bring that also into the elements of confidential computing, which do have the speed and the scale, as you had mentioned. But what is the current approach to stop in-memory attacks, and how do you isolate the attacks using secure enclave technologies from the data core?
I mean, that's a really in-depth question, honestly. Where we're trying to get to is we should have the ability to control data moving within the entirety of the stack. Most of the time, people look at data as far as, well, does it hit the application and can the user get to it? All the stuff on the back end is kind of just taken for, I don't know, the data goes somewhere and it's inside of the thing, and then that makes the application work and the users are happy and no one's complaining, so therefore we must be doing something right. Where in reality, like you're saying, we've got to be able to have controls across the entirety of the OSI model through the total technology stack, all the way out to the cloud application side, so that we can have controllability and manageability of these massive troves of data. And it's only getting bigger by the day, and more people are accessing it because the benefits are showing themselves to be pretty substantial. So I think we're in an interesting space for the next few years in relation to how we deal with this problem.
Great. Thank you for giving that input. And for you, Cheng, I'm curious about your take on the algorithmic complexity attacks and how secure enclaves can help in situations like this.
Well, I think going back to the context, machine learning and data, where if data security is not persistently enforced, then you have a situation where you could have a garbage in and garbage out situation. Especially in the context of machine learning, the truth, quote unquote, that's derived from wrong data could be pretty significantly impactful. But I think machine learning also has a particular attribute. The data that are used by machine learning are diverse and from many different sources. And they tend to be closer to where the data sources are in. Less in a data warehouses environment where data are already formatted, transformed, ready for consumption. So machine learning has the problem of how to use secure data closer to the data sources, which are diverse. That speaks to the importance of trying to protect and create a universal data labeling scheme that's consistent with the ETL processes today, that allow data to be declared automatically, programmably, as data that need to be protected. And through that declaration, that data security is maintained throughout the life cycle. And so for machine learning, I think the first issue is the ability to label data that needs to be securely protected and start protection of the data from data sources and therefore data storage. As related to secure enclave, I think that's where the machine learning model needs to be trained with additional protection. Because that's the area where if the data sources are correctly protected, and granted they will be transported with transport security, then that leads to the vulnerability to be, when machine learning are going through training, the memory exposure of the algorithm that's been executed. That's the part that needs to be further protected. But protecting machine learning data without discretion is very expensive because the sheer amount of data for machine learning is just way too much. And that in a secure enclave situation, you actually have memory constraint. And that in machine learning training, memory is a premium asset because that determines the performance. And so what you really want is two things. One is the ability to discriminate data that need to be confidentially protected versus data which do not. That ability to discriminate between data are not created equal is very important for cost reason, for performance reason. And that need to occur at the very early days of data creation. And secondarily, I think when you have that in use, when you are in use of data, which will be, in this particular case, applied to machine learning training, that you need to have selective data treated differently in selective enclave protected region or not. In order to have the proper protection for data that are inherently securely protected versus data which don't have such a risk concern. But do it transparently so machine learning programs do not have to change, because there is no possibility for machine learning program to be consciously aware of how to make security treatment in order for machine to be trained. That's just impossible from a deployment perspective. So the transparency without application changes, the ability to select data in secure enclave as needed, but automatically assigned to secure enclave as needed, those are important attributes for machine learning to be enabled with secure data at scale. And one last point is all these things, knowing that machine learning are not being executed in one server, but a collection of servers or a collection of locations which are interconnected through a high-speed interconnect or some sort of fabric to tie them together. That speaks to the importance of distributed authorization and or distributed secure enclave.
Absolutely, absolutely. In terms of looking at compliance, the impact of compliance, Dr. Cunningham, in being able to discriminate between data that needs to be protected, data access that needs to be privileged and non-privileged. How do you see this in terms of from a CISO's perspective, or how would you advise CISOs to really look at the compliance, especially within this scope of issues?
Well, this is a space where compliance is super interesting because compliance is already pretty dynamic in nature. I mean, things change almost on a daily basis. So how do you wind up with a compliant system when things aren't just going to stay in that state? Compliance is a snapshot, a point in time, when in reality, systems are not focused on a point in time. They're continually changing and evolving. So in order to achieve compliance, especially continual compliance, you have to be able to do things that will operate at the same speed and growth and diversity and dispersion as any other system. That is not achievable by human beings. It's just not. So you can't have Timmy the intern using a spreadsheet trying to keep up with what's going on compliance stuff and think you're going to get it right. Therefore, that means we're going to have to continue to engage in growth and alignment of compliance technologies. But those compliance technologies also have to continually push the envelope on up-leveling security controls. There's a really kind of dual-sided blade here, and organizations have to be aware of that. It's not enough to say you're good, you're compliant. You're good, you're compliant for that minute. Compliance and those things must continue to progress with the evolution of the system.
So looking at a lot of CNAPP products and GRC products that are trying to patch and to protect from the outside, and then looking at secure enclaves and confidential computing that are protecting from the inside layer out. What is the interconnect here, and how should we be looking at security from at a fundamental level?
Well, good security policy should be the Rosetta Stone that sits between those two things. So that way you're not running across each other. You're not trying to solve for a problem outside that doesn't match to the inside. And we've tried to do this manually for a long time, but I think we're finally at a place where policy engines and the things that operate in that manner can allow those to operate without negative impact to the organization. So I really think that if you're trying to take outside problems and internal issues and mesh them together so that you actually solve the outcome, it's going to be a policy engine that will allow that to occur. That's your Rosetta Stone between those 2 points.
Absolutely. And Cheng, final question for you. What does continuous compliance look like at the machine scale, especially with tamper-proof and tamper-proof logs and audit logs and generated logs in that scale?
Well, I think it's important to look back and say, what really are the problems? I think the problems should be broken into 2 separate categories. One is that is the data never compromised? Is the data in true form that is never compromised? That's one. And second is the access to the data properly authorized? So there should be this should be treated as 2 separate issues. That is that there's a separation of data security versus the issue of how data can be accessed and by whom. Those are the 2 separate issues. I think the present state is that we mix those 2 issues together. Data is not always secure. Anybody can potentially change it. But we try to put it in an envelope of some sort and strengthen the protection of the envelope, but not strengthen to the enough level that we can say for sure 100% that it's never been tampered. And therefore, we try to add a protective layer called access control over that, okay? I think the so-called continuous compliance or things of that nature today is built on top of the assumption that data is not inherently secure. And that's an important notion to remember. And therefore, you try to strengthen the layer outside of that to control access into it in hope that to mitigate unauthorized access to it, even though it still has the inherent risk that data may be compromised somehow, somewhere. And so it's a way to kind of reduce the risk, but it doesn't eliminate the risk. I think the so-called continuous compliance, it really is built on top of the presumption that if data is fundamentally secure, what compliance obligations can be automated, or can be simplified, or risk can be eliminated. And that's more the detail level that we need to talk about. Because you can talk about technology all day long, but it doesn't make any difference. If the data is fundamentally secure and the data log in terms of who accesses it is securely produced, then you know the log itself is 100% genuine. And that itself is a basis of truth to gather additional information from that, right? So that's one aspect, and therefore imply that compliance work can be simplified and can be better automated, as an example of that. The access control right over that, if data is fundamentally secure, then it has the inherent ability to regulate who has access right to access it. And if that access right is supported by a distributed authorization, then it's inherently enforceable anytime, anywhere by anybody. And therefore, it really is a mechanism that allows ubiquitous enforcement and ubiquitous update of policy whenever it needs to be. And so in the context of automation, in the context of eliminating inconsistency of authorization, in the context of making policies properly propagated and enforced at the right time, at the right point, that's the benefit of continuous enforcement.
Right, and this would totally change the attack surface for CISOs or any security that needs to really be able to protect the data. Well, thank you so much, gentlemen. I think we're about at time. Really appreciate having you guys on to share your thoughts, especially after such a hectic week and with so much data dump for the security ecosystem. Thank you so much for everyone tuning into our debrief of the RSAC 2023 featuring AI, data privacy, and confidential access. Thank you.